relations like voltage, current and power. This is the power equation is given here. It is power consumed in each phase is given by, that is power in each phase is equal to VPH IPH cos phi. But here in delta connected load we have to need VL is equal to VPH. Okay, in delta connected load, that is line voltage is equal to phase voltage. Then line current is equal to root 3 IPH. Okay, now this is the relation in delta connected load. Okay, now what? Total power is equal to 3 into VPH. This VPH is given here. This VPH IPH cos phi is put here, but VPH is equal to VL is put here. Okay, then rearrange equation for IPH. IPH is equal to IL upon root 3. Okay, then this value is put here. Okay, that is here IL upon root 3. Okay, now here multiplied and divided by root 3. Okay, then this root 3 into this root 3 we obtain 3. Okay, then this value put here, this 3 here. Okay, and multiplied root 3 as it is. Okay, this here obtain 3. Okay, then 3 to get cancel, then obtain root 3 VL IL cos. And this is the power in delta connected load with respect to VL is equal to VPH and IL is equal to root 3 IPH. This is the delta connected load and their relations like voltage, current and power. Okay, now this is the delta connected load is here. Now we have to need power triangle. Okay, now this is the power triangle is here. Then power triangle is defined as, it will be depends on apparent power, reactive power and active power. That is apparent power, that is symbol is S, is defined as active power plus reactive power. Okay, then formula for active power is P is equal to root 3 VL IL cos phi is here. It is called as active power. Then reactive power Q is equal to root 3 VL IL sin. That is P indicates for active power and Q indicates for reactive power. Okay, now here we have to need apparent power. It is apparent power S is equal to, that is S square is equal to, we are using Pythagoras theorem, that is P square plus Q square. Okay, that is we obtain S is equal to under root P square plus Q square. It is here. Okay, now this is the formula for apparent power, this is the formula for active power and this is the formula for reactive power. Okay, now here the apparent power is here, the apparent power is here measured in volt ampere and kilovolt ampere. Then active power is measured in watt or kilowatt. Then reactive power measured in VAR, that is volt ampere reactive or kilovolt ampere reactive. Okay, now this is the power triangle is here. Okay, now here we have to need total apparent power is here, that is here. Then S is equal to root 3 into VI. Then S is equal to, we have to need phase voltage and phase current, that is VPH IPH. Okay, then formula for VL is root 3 into VPH. Then formula for IL is root 3 VPH. IPH. That is, we have need VPH and IPH. Then rearrange equation for VPH is equal to VL upon root 3. Okay. Then IPH is equal to IL upon root 3. Okay. Then both values are put here. That is, VPH is put here, IPH put here. Then 3 into VL upon root 3 IL. Then 3 into VL IL upon root 3. Then here we have put 3 into VL upon root 3 into IL upon root 3. Okay. Then here root 3 into root 3. This we obtain 3. Okay. Then this value is put here. That is here. Then here we have put 3. Okay. Then 3 3 get cancel. Then obtain S is equal to V into I. Then phase voltage is S is equal to VPH into IPH. Okay. Then same for load, S is equal to VL into IL. Okay. Now this is the power triangle for active power, reactive power and apparent power. Okay. Now this is the power triangle concept. Okay. Now next point is problem based on delta connected load. Okay. Now here we have to need formulas for delta, that is VL is equal to VPH. Okay. Then IL is equal to root 3 into IPH. Okay. Now these are the important formulas in delta connected load. Okay. Now here the problem is given here. Then a delta connected balanced load is connected. The diagram of delta connected load. Okay, now this is the delta connected load is here. Then this is the R phase is here. Then this is the Y phase is here. Then this is the B phase is here. Then here current IR is flowing through it. Current IY is flowing through it. And current IB is flowing through it. Okay, now here delta connected balanced load is connected to the 3-phase 400 volt. Okay, and its power factor cos pi is 0.8 lagging. Then line current, that is IL, is given here. That is IL is equal to 34.64 ampere. Then find resistance, reactance, impedance of the load. Then find out total power, total reactive volt ampere. Then finally draw phasor diagram. That means in this problem we have to need first calculate resistance, reactance and impedance. Then calculate total power. Then calculate reactive volt ampere. And last one is the phasor diagram. Okay. Now this is the given condition is here. What is the meaning of total reactive volt ampere? That is, we have need here reactive volt ampere. That is, we have need active power. That is reactive power. That is Q. This reactive volt ampere is here calculated. That is total reactive volt ampere. That is VAR. That is, we have need reactive power. Okay. Now here first given is line voltage is 400 volt, then cos pi is 0.8. Line current is given here. This IL is equal to 34.64 ampere and delta connected load. Then here line voltage is given here, that is VL is given here 400. Then in delta connected load VL is equal to VPH. Okay. Then phase voltage is obtained here. VPH is equal to 400. Okay. This here obtained. But line current is equal to IL is equal to root 3 IPH. Then rearrange equation for IPH. IPH is equal to IL upon root. Okay. Then here the line current IL is given here, that is 34.64 is put here. Then obtain IPH is equal to 34.64 upon root 3. Then obtain IPH is equal to 20 ampere. Okay. In this problem, first we have calculate VPH, IPH. Then we have to need ZPH. Okay, that is ZPH, that is impedance of the total circuit. That is ZPH is equal to VPH upon IPH. Then put value of VPH is here. Then put values of IPH is here. Then obtain ZPH is equal to 20. Okay. Then here power factor cos phi is given here. That is cos phi is given here. This cos phi is equal to 0.8. Okay. Then here phi is equal to cos inverse of 0.8. Then obtained angle is 36.86 degree. This we will calculate phi is here. Okay. But we have to need total impedance of the load. But Z is equal to R plus JXL. This is the total impedance. But in this problem, resistance is not given, inductance not given. Then we have to need ZPH is equal to ZPH angle theta. That is, we have to need polar form. Okay. Then here ZPH is calculated here. This here 5. Then here put ZPH is 20. Okay. Then angle is find out phi is 36.86. Is put here. This we have calculate total impedances with the help of polar form. That is ZPH is equal to 20 less than 36.86 ohm. Then this polar form it will be calculated in the form of rectangular form. That is, we have to need polar to rectangular form. Then here obtain R plus JXL. JXL. That is, RPH is equal to obtain 16 ohm. 16 ohm per phase. Then XL PH is obtained 12 ohm per phase. Okay, now this is the in given condition. First we have to find out resistance. This resistance is here. Then reactance is here. Then impedance of the load is here. Now we have to calculate total power and reactive power. This total power symbol is P. That is, we have to need find out P. Then we have to need find out reactive power. That is, we have to need Q. And also here we have to need total power. Then total power, that is symbol S. S is equal to P plus Q. Okay. Now here P indicates for active power, Q indicates reactive power. Then we have to need calculate both P plus Q. That is, here calculate P, here calculate Q. Then formula for P is equal to root 3 VL IL cos phi. Then put here VL is equal to 400. Put here, then IL is given here 34.64. Then power factor is given 0.8. Then obtain active power is 20 kilowatt. Then reactive power Q is equal to root 3 VLIR sin phi. Then root 3 as it is, VL given here, IL given here. Then sin power factor is 0.8 is given here. Then obtain 14.339. Then we have calculate yes, that is total power is P plus Q. Then 20 plus 14.30. Then nearly obtain 34.30. This is the total power in delta connected load with respect to active power reactive. Okay, now this is the problem based on delta connected load. That is, in delta connected load there are two conditions, that is VL is equal to VPH and IL is equal to root 3 IPH. Then we have to calculate VL, then we have to calculate ZPH, then calculate phi, that is cos phi. But here the resistance inductance value is not given here. Then we have need polar form, it is ZPH less than phi. Then put ZPH is equal to 20, then phi is equal to 36.86. Okay, now we have obtained resistance value is 16 ohm per phase, then obtain inductance value is 12 ohm per phase. Then we need power, that is active power and reactive power. Then we have calculate active power and reactive power. Then we have calculate total power. Okay, now this is the problem based on delta connected load. Then we have to need phasor diagram. Is we have to draw phasor diagram with the help of angle 36.86. Okay, now we have to draw phasor diagram. Okay, now this is the phasor diagram is here. Okay, now here first we have to need VRY. We have need again IRY. Is here. VRY is here. Then IRY is here. Then we have to need angle between them. Phi is 36.86. That is here. Phi is here. Okay. Now we have to need VYB. Okay. Then we have need IYB. Then angle phi is given here. That is, first we have to draw VYB, then current IY is here. And angle phi is here, 36.86. Again, we have need VBR and IBR. Okay, that is here. VBR is here. Then IBR is here. And phi angle is here. Okay, that is VBR is here. Then IBR is here. Okay, that is we have to draw angle is phi is 36.86 is given here. That is phi is equal to 36.86. Okay, now this is the reference phasor with respect to voltage and current. Then we have to need to draw IR bar. What is the formula for IR bar? It is here. IR bar is equal to IRY minus IBR. It is IRY is here and minus IBR is here. This is the magnitude of IR bar is here. Okay, now this is for R phase. Then same for Y phase is we have to need for Y phase is magnitude of IY bar is equal to here IYB minus IRY. Is IYB is here, then minus IRY is here. Then we have draw IR bar is here. Okay, now this is for Y phase. Then we have need B phase. That is we have need B phase is here. That is we have need IB. Okay, then IB bar is equal to IBR is as here. Then minus IYB, that is here. And this is for magnitude of IBR. Okay, now this is the phasor diagram for delta connected load. In delta connected load, first we have to need VRY, then VYB and VBR. This we have to need. Important parameter is here. First VRY, then VYB and VBR. Then we have to need current is IRY, then IYB is here and IPR. Okay. Then we have to need current IR bar. Then we have to need current IY bar. And we have to need current IP bar. And we have to draw phasor diagram for delta connected. Okay, now this is the diagram for delta connected load. Okay, now at this stage, unit number 4, part A, that is polyphase AC circuit, is completed here.